Good afternoon, everyone, and welcome to this lecture. This is lecture number 9. We are dealing with RC circuits, and we are supposed to finish this in today's class only. What was the last thing that we did in yesterday's class? Do we remember? We had seen how to find out the charge in steady state on the capacitor. Do we remember these questions where we had seen the transient state of capacitor?
Yes, sir.
And we had to find out the charging. We have to find out the charge on the capacitor in the transient state. We had also seen how we can find out what the steady state charge of the capacitor. We had done some question where we had found out the steady state charge on the capacitor. Everyone understands this? Everyone remembers it? Yes or no?
Yes, sir.
We are done with I think charging of capacitor. Now we have to see the discharging of the capacitor. So we'll move ahead with discharging of the capacitor. But first we have to understand that before discharging the capacitor has to be initially charged. Do we understand this?
Sir.
The capacitor has to be initially charged before getting discharged. So normally the charging circuit is given together with the discharging circuit. So we'll start with the heading discharging of capacitor. Discharging of capacitor. And to understand this discharging of capacitor, you can see a very simple example. A very simple example of this particular circuit, which comes on your screen right away. Now let me just change the value so that we understand something. Let me call this resistance as R1 and let me call this resistance as R2. Now what you see over here is a two-way switch. Here you have what you see here is a two-way switch. You understand the meaning of a two-way switch? Do we understand the meaning of a two-way switch? Do we understand the meaning of a two-way switch? Are we there in the class? No one seems to be there. Am I audible and visible to all of you?
Yes, sir.
Yes, I asked you a question. Do we understand the meaning of a two-way switch? Anyone?
Understood, sir.
What is a two-way switch? What do you understand by a two-way switch? What is a two-way switch? I'm asking you a question. Either you say you know the answer, you tell me the answer, or you tell me that we don't know the answer, sir. So I'll go ahead and do
Don't know
my
the answer, sir.
Okay, that's better. It's not worthy wasting time. A two-way switch is a switch we can connect at 2 points. So this is a two-way switch. So in case number 1, which I will draw as red, the switch is put at point 1 so that this circuit, the pink circuit, gets completed. When the pink circuit gets completed, what will happen to the capacitor? The capacitor will get charged. Do we understand this?
Sir.
At time t is equal to 0, switch Number 1 is on. It can only connect to one point. It can only connect to either point 1 or it can connect to point 2. So at time t is equal to 0, the switch is switched on. So what will happen? The capacitor gets charged. Do you understand this?
Sir.
Now the capacitor gets charged, and in this case, what will be the steady state charge on the capacitor? Can anyone tell me? So I'm charging the capacitor. What will be the steady state value of charge on the capacitor in this case? What will be the value of charge that the capacitor will get? Is it a difficult question? Is it a difficult question for me to ask? You cannot tell me what will be the charge on the capacitor finally when the capacitor gets charged. That is what we have done in the previous class. Yes.
JEE minus IR.
Take a deep breath, the deepest breath in the universe. Look at the question and then give me the answer. What is the final value of charge that the capacitor will get? It seems that you have not gone through what we had done in the previous class. No one remembers what is the final charge on the capacitor? That would mean that the class that we did yesterday had gone to waste. One more thing down the drain of Hyderabad. Anyways, this is what we did. So I'll request you once more to please go through this, having this right in front of your eyes. Now can you tell me what is the charge on the capacitor in the case that I have just shown to you? Take a deep breath and open your eyes and see better. You need to take a deep breath. Open your eyes. Tell me what is the answer now. What is the final charge on the capacitor? The capacitor is connected to point 1 and I allow it to charge. For a long time I allow it to charge. What is the charge that the capacitor will get? Yes. No one knows it? I'll give you 5 minutes. Go through what we had done in the previous class and give me the answer for this one. Go back and see what we had done in the previous class. It seems like we have not gone through what we have done in the previous class. So this class will be a waste then. Please go back and tell me the value of charge that the capacitor will get finally, steady state, after a long time. I'll give you 5 minutes. Go through it. I'm expecting a question from this part, and that is why I'm insisting so much. If there's anything that you don't understand at any point in time, please ask. So I connect it to point A. After a long time, the capacitor will get the steady state charge, and the charge on the capacitor will be C into E. You have done a couple of questions, and I just pray to God that you remember them, how we had found it out. Anyways, in this case, the answer is C into E. Now, this is the final charge the capacitor gets at after a long interval of time. Now, this connection now has been disconnected. So now the capacitor is disconnected. Now, in the second case, what is going to happen? Now, the switch is put at point 2. And now I start the time again at time t is equal to 0. Now I'm starting the time again. I have switched the switch from point A to point B. Initially, it was at point A, the capacitor got charged. Now, once the capacitor is charged, now I put the switch to point B. Now, the capacitor got charged. This was the positive terminal and this was the negative terminal. Now, the capacitor got charged. Now, what will happen? Once the switch is put to point number 1, okay, before asking you that, the pink circuit, and that is a question that is being asked. In the pink circuit that you see, the capacitor was getting charged. What is the time constant of that charging circuit? So let me call this as tau C, C standing for charging. What is the time constant of this charging circuit? Can you tell me that? What is the time constant of this charging circuit? Can you tell me that? That is a question that has been asked almost in all times in JEE. What is the time constant for this charging circuit? I hope you remember the word time constant. What is the time constant for this charging circuit? Yes.
RC, sir.
Take a deep breath. Open your eyes. You have got big, beautiful, wonderful eyes. Open them. Look at the diagram. Look at what is C and what is R. Look at what is C and what is R. Look at what is C and what is R. And then give me the answer again. So I give you one more chance. What is the time constant of the charging circuit?
R1C.
Yes, beta?
R1C.
Yeah. So you see the answer has changed. The You have to understand that difference is not in saying it RC and R1C. You have to understand that it is getting charged through the resistance R1. That is why I have called it R1. And I'm going to call the second one as some other name. So the time constant of this circuit is R1C. Everyone understands this? The time constant of charging of this circuit is R1C. Now let us go back to what we were doing. At time t is equal to 0, the switch is put to position number 2. At time t is equal to 0, because now I am going to start the time again. Now as soon as I put the switch to switch number 2, battery goes out of the circuit and now the circuit gets completed in this fashion. Do we understand this, everyone? Now the green circuit comes into the picture. We understand this? Yes?
Yes, sir.
And now the current in the circuit will flow like this. Yes or no? And now the capacitor will start to get discharged. The charge on the capacitor will change from the value it had, and slowly, in fact, it becomes 0 very quickly. It will become 0. That process is known as the discharging of the capacitor. So what we have to find out is the value of charge on the capacitor as a function of time. So how I'm going to do this? I will just write the final result because that is the one that is important to us. Q is the charge on the capacitor at any time will be equal to Q naught. What does Q naught stand for? Q naught stands for charge on the capacitor at t is equal to 0. Do we understand this? T is equal to 0 means this time where I have started the discharging process. Do we understand this?
Yes, sir.
Or let me not write it as Q0. Let me first write it in the original form. So the initial value of charge, my dear friends, was C into E. That is how it was charged. E to the power minus T by the time constant of this circuit, and the time constant of this circuit is going to be R2C. Do we understand what I have done here, what I am doing here? Yes or no? No or yes?
Yes, sir.
What? Okay, now I can write this Q is equal to Q naught e to the power minus t by tau. Now I am going to write it in this fashion, and now we are going to see what all these things mean. What does Q naught stand for here? Can anyone tell me? What does Q naught stand for here? Q naught stand for the charge on the capacitor at time t is equal to 0. And in this case, the value of Q naught is C into E. Do we understand this?
Yes, sir.
This tau is the time constant of the discharging circuit, and here it is equal to R2 into C. R2 into C. Tau D for discharging is R2 into C. As you can see, it is different from the charging circuit because the resistance ka value is different. It could have been same as the charging circuit if the value of resistance would have been same. We understand this much? Yes or no? Yes or no? We understand this much?
Yes, sir.
I'll give you 2 minutes to note it down. Once you are done, bacha, please let me know. Okay then. Here again we come across this word which is the time constant of this circuit. Here it is the time constant of the discharging circuit. So we must now try to understand what is the time constant of the discharging circuit. First of all, if you put the value of at t is equal to 1 tau, if you put the value of time if you put the value of time as 1 tau, what is the value of charge that you are going to get? Because from that we are going to define the time constant of the discharging circuit. So when I put the value of time as 1 tau, the value of Q will be coming as 0.37 times Q naught, or the initial value, which is nothing but Q naught divided by E it will come. So from here we can write the definition of the time constant. The time constant of the discharging circuit is the time taken by the circuit or the capacitor to decrease its charge from the maximum value to 37% of the maximum value. Do we understand this? Everyone understands this, what I am saying here?
Sir.
And if you draw the graph between the charge and time, the graph, again it's an exponential graph, and the graph will look like this. At very long interval of time, it's an exponential graph. So after a very long time, the charge will become 0. And after a very long time, the charge will become 0. Theoretically, it never becomes 0. Theoretically, it never becomes 0, but you can understand that practically, even after some milliseconds or some microseconds, the charge becomes 0. Do we understand this?
Sir.
Everyone understands this? I'll give you 2 minutes to note this down. Okay then, we have seen what is the time constant. Remember, one more important thing, the dimension of this time constant. And I think I have told you that before also. The dimension of this time constant RC is the inverse. The dimension of time constant, since it is a time constant, it is same as the dimension of time. Did I tell you that? Yes or no? Remember
Sir.
this. You should not forget this. Now, they can also ask you what is the current in the circuit at any time. So remember, current in the circuit will be given as minus dq by dt, because the charge is coming down, the charge is falling, and therefore I have written it as minus dq by dt. And if I find it out, it will come as E by R2, E by R2, e to the power minus t by RC. You can write this current like this: I is equal to I max e to the power minus t by tau. R2C I must write, so that you understand that R2 come. Where what is the value of this I max? This I max is the current at time t is equal to 0. That is the time when it is maximum. And I max is E by R2. We understand this? Yes or no?
Sir.
Okay, I will give you one more point and then I will give you time to write it down. The next question that they can ask is what is the potential difference across the capacitor as a function of time? V is equal to E, which was the original potential difference, e to the power minus t by tau. Do we understand the meaning of terms here? Yes or no?
Sir.
This is the discharging circuit, my dear friends. Now I'll give you 2 minutes to go through this entirely, and then we can move on to other questions. I'll give you 2 minutes. Let me know once you are done. Well, then I will, what I'll do is just to give you a quick recap of both the charging and the discharging. I will give you a table where both of them are put together side by side, so that you can compare them and understand both of the circuits together. Note them down carefully. Do not make a mistake. I'm expecting, I don't know why, a question from this section, from this part in this year's paper. May not be in all attempts, but in some attempts. So this is your charging and discharging kept side by side. When a capacitor, resistance, battery and key is connected in series and key is closed, then the capacitor begins to charge. VR, you can, E is the potential difference, or E is the EMF of the battery. VR is the potential difference across the across the resistor, and VC is the potential difference across the capacitor. We understand this? We
Sir.
understand this? When a charged capacitor and a resistor is connected together and the key is closed, the capacitor starts to discharge. VC is the voltage across the capacitor at any time, and VR is the voltage across the resistor at any time. Do we understand up till here? First listen to me, then I'll give you time to write. Do we understand up till here?
Yes,
Yes,
sir.
Okay,
sir.
first write up till here, because the next thing is a bit long. So write up till here. Let me know once you are done. Note up till here the diagram, then we'll move ahead.
Minute, sir.
Okay, then let's move ahead. Up till here, I think everyone has noted down. I'll just keep that diagram here, and then I will try to put the rest of the part. Let me see if I can put the rest of the part. Okay, Now this is the rest of the part. To find out the charge or the potential difference, I have listen to me very carefully, beta. I've already given you all these things. Here everything is put in this. Total potential drop or the potential of the battery will be equal to Vc plus Vr. Do we understand this?
Yes, sir.
And in this case there is no battery, so Vc plus Vr is equal to 0. From this you get a quadrant, you get a differential equation, which you can see. I'm not concerned with that. And solving that differential equation, you will get the value of charge on the capacitor as a function of time, which is given in this bracket. We understand this much?
Yes, sir.
This part, this is the charge on the capacitor in charging. When it is charging, the one on the right hand side is while it is getting discharged. Here they have taken both the resistance as same, therefore you find the time constant as same. But I told you that the time constants can be different. In one time constant, the charge becomes 63%, from 0 to 63%. Here in one time constant, the charge becomes from maximum to 37%. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note it down then. Everything side by side. Well then, let us move forward and write the last part of this. Current at any instant. In first case, you can find it as plus dq by dt. In the second case, you can write it as minus dq by dt. So it becomes, yes, beta?
Sir, we are writing, sir.
You did not write it. Okay. So write it. And once you are done, please let me know. Okay, then now we can move ahead and write the value of charge and the potential across the capacitor as a function of time. Remember, this is a potential across the capacitor and not the resistor. We already know the values, yes or no? So you can note this down. Everyone knows this, yes or no? I'll give you 2 minutes to
Yes,
note it
sir.
down. Then let's move on and solve one or two questions based on this. Let's see if you can do this one. Remember, all the questions are simple, and I hope that you can do this one. This is a question from your favorite book, and I hope that you can do justice to this question. Take your time, think about the question, and tell me the answer. And the question goes like this. Electric field. Oh, electric field. We talked about potential, we talked about current, but never talked about electric field. I will leave it to you how you do this. If you understand the concept, you must and you will get the result. The electric field between the plates of a parallel with capacitor of capacitance 2 microfarad, capacitance given, drops to 1/3 of its initial value in 4.4 microseconds when the plates are connected by a thin wire. Find the resistance of the wire. So in which category does this question lie? Does this question lie in the category of charging of capacitor, or does this lie in the category of discharging of capacitor? Which category? Charging or discharging? Is the capacitor getting charged or is the capacitor getting discharged?
Discharge.
Discharge. So now the stage is open for you, and I'll wait for 2 minutes, 3 minutes for your answer. Remember, you might not be able to give me the complete answer because there might be something coming which you don't know the value about. But you can get to that stage, I would be pretty happy. Your time starts now. So how are we supposed to do this? We have not seen the formula of electric field. How will I find out the electric field? Any idea? I have to find out the electric field between the plates of the capacitor. How will I find out the electric field? Anyone, any idea? Obviously, no one knows it.
Q charges positive and negative on either plates.
So, how can I find out the electric field?
Find the electric field
How?
between the plates.
Can you give me any formula for that?
A epsilon naught into by D.
Yeah, beta? Yes, tell me.
Electric field between the parallel plates is 2A epsilon naught by D.
No, that is not correct. Okay, so you can do it in many ways. To find out the electric field, you know the potential difference between the plates. Yes or no? You can just divide it by the D. That is one way of doing it. Or you can find it out by Q by A epsilon naught. So these are the two formulas that you can use. Anyways, basically, whatever formula you apply, whatever you see in the denominator of any of these formulas, whether it is D or A or epsilon naught, they are always going to remain constant. They're always going to remain constant. So we had the formula. If I write the formula for charge on the capacitor, this charge on the capacitor is Q naught e raised to the power minus t by tau. The formula for voltage drop is V naught, initial voltage, e raised to the power minus t by tau. On similar lines, I can write the formula for electric field. Electric field will be equal to E naught, the initial electric field, e to the power minus t by tau. That is the only thing that you had to understand, that the formula of electric field will also be similar. Now at time 4.4 microseconds, it is given at 4.4. At time 4.5 microseconds, the electric field drops to 1/3. The electric field dropped to 1/3 of its original value, so it becomes E naught by 3. E naught by 3 is equal to E naught into e to the power minus t by tau. E naught goes away. E naught goes away. And I take log on both sides. I hope you understand how to take logs. So what will I get? I will get t by tau as ln of 3. I will get t by tau as ln of 3. T by RC will be equal to ln of 3, my dear friends. And from here, I can find out the resistance of the wire, bacha. The resistance of the wire will be T by C multiplied by ln of 3. T is known, C is known, ln of 3, the value would be given. That is the answer, my dear friends, that I was expecting from you. And you just had to understand that the formula of electric field will also be similar to the formula of charge or voltage or anything, because it comes from the charge or it comes from the voltage. I will give you 2 minutes to note this down. If you have any problems, any doubts, please come up. Well, then comes this question on similar lines. They've asked something in the first question. They've asked similar thing in a different question in a different way. A capacitor is charged to 50 volts, so that is the initial voltage, is discharged by connecting the plates at time t is equal to 0. Similar conditions. The potential difference across the plate drops to 1 volt at 10 microseconds, 10 milliseconds. I'm sorry. What will be the potential difference at 20 milliseconds? Beautiful question from your favorite book. 2 minutes you have to give me the answer, and I hope that I get something that looks like an answer. You may not be able to get the exact answer, but I'm happy whatever you get, because whatever you get will be one of the options that are given. 2 minutes you have. I'm listening. What are you saying, beta? The potential difference is given original potential difference, original battery, which is what charged to is 50 volt. In 10 seconds, 10 milliseconds, it has become 1 volt. You have to find out the potential difference at 20 milliseconds. Yes, what you have done? Can anyone tell me? I have given you some time. Can anyone tell me what you have done? Can you tell me any formula that you applied? Any concept that you applied? No one has applied any concept. No one has applied any formula. No one? Anyone has any idea which topic this is from? Which topic this question is from? Do we have that idea, beta?
Capacitors with initial charge.
So the capacitor is discharging or capacitor is charging?
Charging, sir.
It is charging. Capacitor
Discharging, sir.
is discharging. So what is this 50 volt given as? What is this 50 volt? Why is this 50 volt given? No idea? Anyone can tell me what is this 50 volt? Can anyone tell me the formula of discharging of capacitor? Any formula that you remember? Can anyone tell me any formula of discharging of capacitor if you remember? We have written it 2 or 3 times. No one remembers it? Is that so? Okay, I'll give you 5 minutes. Go through the formula and tell me the formula that we have to apply. We have done discharging of capacitors. Please go through them and tell me which formula I need to apply here. Please let me know once you are done. Are we done, beta?
Sir.
Everyone has understood what we have done?
Sir.
Well, then this is the question that comes up for you. The question from JEE Advanced. Find the time constant for the given circuit. The same question can come in your JEE Mains. They may not even change the values. Find the time constant for the given RC circuit in the correct order. The first one is the top left. Then we have the second one, top right. Then we have the middle one. What is the time constant for the circuit? R1 is given as 1, R2 is given as 2, C1 is given as 4 and C2 is given as 2 microfarads. The answer has to be in microseconds. I'll give you 2 minutes to give me the answer for this one.
Option B, sir.
Which option is correct? Option B. Yes, that is correct. You just have to find out time constant. Time constant is R into C. You just have to find out the resistance here. The resistance here is 2 plus 1. It will become 3. And the capacitance are in parallel. This will become 4 plus 2, 6. So the first has to be 18. So the options which are correct are either A or B. The rest are wrong. Then you can move on to the second one. 1 and 2 are in parallel. So it will become 2 by 3.
8 by 6.
Yes, beta.
So, capacitors 8 by 6.
I don't understand what you are saying. Anyways, C1 and C2 will be 8. Oh, okay, you are telling me the value of C1 and C2. 8 by 6 is to multiply. I think you are going to get 8 by 9, and therefore the correct answer is option B. Do we understand this, or this has gone above our head saying bye bye?
Sir.
This is the next one, and let's see who gives me the answer for this one. Any of these questions can come in your JEE. Everyone got this one? Yes or no?
Yes, sir.
You can see the sort of questions that we have done are very difficult compared to what the questions are there that are going to come in your exam. This is JEE Advanced. One more question from JEE Advanced. This is 2004 and 2 marks question. Capacitor is charged using an external battery with a resistance X in series. The dashed line shows the variation of ln. ln, natural log. ln of I means current. This is natural log of current, ln of I. ln of I, remember, ln of I with respect to time. If the resistance is changed to 2 times x, so I make the resistance 2 times, which is the new graph, and your time starts now. So this is the question of charging of capacitor, and they're asking us something between I and T. Do we know anything about the current in the capacitor for a charging circuit? Do we know about that? Do we remember any formula that relates I with T? Anyone? Anyone remembers any formula of I and T in charging?
Is equal to E by R into E power minus T by RC.
That's it. And that as soon as you write that, as soon as you write that answer, you have the answer in your hand, because this is all maths now, nothing with physics. Physics ends on the first line itself. This is what physics can do. Physics cannot do anything else. Now remember, this I naught is basically your maximum current, and that is E divided by R. Yes or no?
Yes, sir.
If you make the resistance twice, the maximum current becomes half. Yes or no?
Yes, sir.
So the maximum current cannot increase. So these two graphs are gone to Bhagwan ke paas. Yes or no?
Yes, sir.
Physics has got nothing to do with this. It's not a question of physics at all. So either it is P or it is Q. Now, if I take log on both sides, nothing to do with physics, only maths. If I take log on both sides, it will have ln of I, which is the graph, will be equal to ln of E by R. That is just a constant term. That is the intercept. We don't have to worry about it. Minus T by RC. This minus T by RC, y is equal to mx plus c, y is equal to mx plus c, y is equal to mx plus c. This minus 1 by RC is the slope of the graph. Minus meaning it is negative. Both the graphs are having negative slopes, so both options may be correct. We just have to see which has larger or which has the smaller slope compared to the original one. When you increase R, slope decreases. So if the original slope was like this, the new slope must be less. It cannot be more. It has to be less. It cannot be more. It has to be less. It cannot be more. It has to be less. It cannot be more. It has to be less. The only option that is matching this is option Q, and hence the correct answer is Q. Do we understand this, or this has gone above our head saying bye bye? Bye bye.
Understood, sir.
Congratulations if you have understood this. Comes a question from your previous year JEE, and I hope you can do justice to this one. This one. A capacitor is connected to a 20-volt battery. I hope you understand what is happening here. Through a resistance of 10 ohms. I hope you're understanding what is happening here. It is found that the potential difference across the capacitor rises to 2 volt in 1 microsecond. What is the capacity of the capacitor? I've given you so many questions, and see, same question has come in JEE. Same question. 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 You have 2 minutes to solve it. Option 2 is correct. Well done. Chalo. The hard work that we are putting in is proving to be useful. The only formula I know is V is equal to V naught 1 minus e to the power minus t by tau. Tau is RC. V is given as 2. V naught is given as 20. 1 minus e to the power minus t by RC. Why is e becoming 0? So if I solve this, I will end up here e to the power minus t by RC will be equal to 9 by 10. So t by RC will become ln of 10 by 9. Everything is given. You can find out the value of capacitance, and from where I see, the answer that is given to me is 0.95 microfarad. If you have got this, congratulations. Did we get this, or this has gone above it saying bye bye, bye bye, bye bye, bye bye, bye bye, bye bye? Everyone got this? Huh?
Yes, sir.
Okay, sir. Then that takes us to the last, almost the last part of this chapter, and similar to what we had done previously, but now I'm going to ask you something else. So take a deep breath, because I'm going to ask you what we did in the last class, and probably that you are not going to remember it. So I'm going to say things. It keeps on going. Question. We had done some question like this in the previous class. There was a switch. Do we remember such question? At time t is equal to 0, the switch was switched on. Then you had to find the current in all the branches. At time t is equal to 0 and at time t is equal to infinity. Yes or no? Do we remember this? Something of this sort? Or we have forgotten it? Huh?
Yes, sir.
You remember it?
Yes, sir.
That question is already done. There is no point of doing it again. Now, the basic point of this question is when the switch gets switched on, the capacitor starts to get charged. Yes or no?
Yes, sir.
We had
Uh,
also we had also find out the final charge on the capacitor. Yes or no?
Yes, sir.
The question now I am going to ask is what is the time constant of this circuit? What is the time constant of this circuit? Now, how are you going to find out the time constant of this circuit? Now, this circuit is very simple. The time constant is actually right in front of your eyes because you can see how is this capacitor going to get charged. Remember, there is no resistance here or no resistance here or no resistance here or no resistance here. So basically this battery is actually connected across this capacitor and resistor straight away. Yes or no? Do we understand this? There is no resistance in between.
Yes, sir.
The battery is actually directly connected to the resistor and the capacitor. Yes or no? So you don't actually have to do anything. You just apply some common sense and not physics. And just looking at the common sense and the circuit, you can tell me the time constant of this circuit. Yes or no? What will be the time constant of this circuit?
R2C.
Yes. The time constant of this circuit is going to be R2C. Do we understand this? Yes or no?
Sir.
Everyone, I am not hearing all voices. Everyone
Sir.
can understand the time constant of this ding 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 ding. Everyone can understand, yes or no?
Yes, sir.
If I change this circuit just a bit, get the time constant because now things become slightly complicated. If I just put the circuit like this, even like this, C, this is E, this is 6 ohms, and this is 3 ohms. Now, if I ask you, I've just changed from one resistance which was actually here. I've just shifted it to here and I've just given you the values, nothing else. From here, I've shifted the resistance here. Now, if I ask you the time constant of this circle, see, there is a resistance that has come here. Do we understand this? There is a resistance that has come here. Do we understand this? Yes or no?
Yes, sir.
There is a resistance that has come here. Now, because of this resistance, you just cannot say that you can understand the difference between the left hand side figure and the right hand side figure. Yes or no? Now, the circuit is just not like a simple circuit where you simply can say it will be equal to 6 into C because that is not the correct answer. Now, how do you find out the time constant in such a cases? Now, remember, there is a trick to find out the time constant in this cases. And the time constant in this case is, please listen to me very carefully. The time constant in this case is is given by this formula R Thevenin multiplied by C. RTH is known as the Thevenin's resistance. This is known as the Thevenin's resistance. So Thevenin's equivalent resistance. Now, what is this Thevenin's equivalent resistance? We don't have to go into much theory. We'll just try to find out. We'll just try to understand how do you get this Thevenin's equivalent resistance. Now, to find out this Thevenin equivalent resistance, remember we have to find out the time constant of the capacitor. So, what do I do? These are the 2 points, A and B. We have to find the equivalent resistance between points A and B, which is the plates of the capacitor. Do we understand this?
Yes, sir.
We have to find out the resistance between point A and B, which are the plates of the capacitor. Now, to find out this resistance, what I do, there is a short trick. What we do, just to find out R Thevenin, remember, just to find out R Thevenin, we will short this battery. This battery becomes short. This battery becomes short, so you remove the battery and short the circuit, and you just find the equivalent resistance between A and B. Short the battery. Short the battery. Step number 1. Short the battery. Step number 2. Find R equivalent between the plates of the capacitor. Battery has been shorted. Now remember, this point A is actually this point A. Yes or no?
Yes, sir.
This point B is actually this point B. Yes or no?
Yes, sir.
So you basically have to find the equivalent resistance between A and B. Battery has been shorted. Now look at A and B. How are the two resistors connected? Between A and B, how are the two resistors connected? Between A and B, how are the two resistors connected?
Parallel.
What is the equivalent resistance?
Sir.
2 ohms. So my Thevenin's equivalent resistance, my dear friend, simply becomes 2 ohms, and my time constant becomes 2 multiplied by C, whatever the C is. That is how we can find out time constant for circuits like this. Even in this case, even in the original case, we can find out the time constant like this. What you do to find out the time constant, bacha? You short this battery, ding, 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 ding. You have to find out the equivalent resistance, no, equivalent resistance between this point A and this point B. Do we understand this? Yes or no?
Yes, sir.
Now, this branch has been shorted, therefore this resistance is shorted, it goes out of the circuit, no current will flow through this, yes or no? So the equivalent
Yes, sir.
resistance between A and B simply becomes R2, and therefore your answer for this case is also R2 into C. So even the original case can be done by the Thevenin's resistance. Do we understand what I have done here?
Yes,
Sir.
sir.
Everyone has understood what I have done here.
Yes, sir.
Take a deep breath. Draw the diagram carefully and write the process. Then I'll give you a question so that you can feel confident. Draw the diagram. I'll give you a question where you have to find out the time constant of the circuit. Are we ready for the question? Or still noting down?
Yes, sir.
What, sir? We are ready for the question?
Yes, sir.
Yes, beta? You want time?
Yes, sir.
Let me know once you are ready, then we'll move ahead with the question. Then here comes the question, sir. You have to tell me the time constant of this circuit, sir. Your time starts now, sir. So how are you supposed to do this? We have to find the equivalent resistance between these 2 points. Yes or no? What do? We take this battery out and short it. Yes or no?
Yes, sir.
So this is shorted. Dung, 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 dung. Now we have to find the equivalent resistance between points A and B. These two resistors will come in what?
Parallel, sir.
Parallel, sir.
2, 4 and 4 in parallel becomes how much?
2.
2. Then this 2 and this 2 will come in what, sir?
Series.
2 and 2 in series becomes how much, sir?
4.
4. Equivalent resistance is 4. So my dear friends, your tau becomes 24 microseconds. Do we understand this?
Yes, sir.
That is how you can find out the time constant of any given circuit. Everyone has understood this?
Yes, sir.
Then we will wind off this class with a question from JEE Advanced that will sum up our class for the day, and let's see who gives me the answer. Take a deep breath and solve this. This is the last question on electric current. Tomorrow we move on to magnetic field and other challenges in life. 2 minutes you have to show your talents, else I will have to show mine. And remember, we have done the same question, same question, same question, same question, same question, same question, and same question come in IITs. Calculation mistake here and there. Anyways, how you have to do this? We have already told you that the total potential drop, the battery voltage is equal to VR plus VC. Yes or no? The value of V naught is VR plus VC. What is given is VC is 3 times of VR. Yes or no? Yes or no?
Yes, sir.
So from there I can find out VR will be VC by 4. Oh, sorry. VR will be V naught by 4 and VC will be 3 V naught by 4. Yes or no?
Yes, sir.
And then the same question, sir, which we have done so many times, sir. V is equal to V naught 1 minus e to the power minus t by tau. We have done it so many times now. This is 3 V naught by 4 is equal to V naught into 1 minus e to the power minus t by tau. Bidding, bidding. If I do, I will land up with e is equal to power minus t by tau is 1 by 4. So basically what I will get is t by tau is ln of 2 square, which is 2 times of ln of 2. Do we understand this?
Yes, sir.
That's it, sir. From here, you can very well find out your t by 2 times of ln 2 is equal to rc. So multiply this. Oh, rc is given to you. You just have to find t. Sorry, I was finding out rc. So your t will be equal to RC multiplied by 2 times of ln2. The answer comes out to be 13.86 seconds or microseconds, whatever. Do we understand this? Everyone got this? Yes or
Yes,
no?
sir.
Yes, sir.
You understand how this is done?
Sir.
Congratulations, we are done with your electric current. A big thing. Electricity is completed. Electrostatics with electric current is done, but electric current is not going to leave uh, our sath, it will keep with us because we are done with only one effect of electric current, the magnetic effect of electric current. is going to start from tomorrow. So that is the next chapter, magnetic effect of current. We'll start it from tomorrow. I hope everyone has understood what we have done in today's class. Yes or no?
Yes, sir.
Then take care. May God bless all of you. Bye bye.
Bye, sir.